John Muir, the father of the US national parks, once said that when one tugs at a single thing in nature, he finds it attached to the rest of the world. It is an observation that resounds loudly in this modern, globalized, interconnected world. But if we look at the 20th century, we see that a different view of the world is pervasive. A view that things were mechanistic and predictable, neatly calculable in a formula. How did we go from that world to the world we live in today? How did a reductive approach give way to an acknowledgement of complexity? This is a story of how ecology was reconceptualized and how this new view was spread to the rest of society. Perhaps a good example to illustrate the 20th century approach is intensive agriculture, the triumph of the Green Revolution. During a period where mass starvation was at the doorstep, intensive agriculture stepped in instead, saving billions from hunger. The prevailing goal was to bring stability to a system, manage the inputs into a system in balance, and reap the predictable outputs. Fields upon fields were built on this platform, this linear, mechanistic understanding of nature. Let's take a closer look at some of the formula of the Green Revolution. We start in the 20th century in the Goulburn Broken Valley in Australia. This is how it went. They identify a single cause for their low yields. Rainfall fluctuates drastically week to week, and their water supply is unreliable. With this formula in mind, they solve for X, irrigate for a reliable water supply. They do so and yields increase. Yes, they think, just as expected, increased inputs leads to increased outputs. Another optimization is spotted. Lots of land is still natural vegetation, but given that water does not limit them anymore, they turn the whole valley into crops. But, over time, problems arise. The crops that had replaced the natural vegetation used less water, and with the additional water from irrigation, the water tables begin to rise. They rise and rise, bringing salt into the soil and local rivers, and waterlogging the soil. Then, to top it off, a flood occurs in 1973, in an area that had previously been more vulnerable to dry periods. Unintended consequences come to bear, and the formula falls apart. Ironically, in an attempt to stabilize the system, a crisis resulted. Next, let's look at fertilizers. It's a straightforward idea. Maximize yields in proportion to inputs. So with the invention of inorganic fertilizers for nitrogen, potassium, and phosphorus, and the invention of crop varieties that can consume more nutrients, crop yields were increased 2 to 4 times and took a shorter time to grow. This was an incredible achievement, a triumph, and it was critical to feeding billions of people. Yet, there were and are several hidden costs that were not predicted. Firstly, fertilizers release greenhouse gases, plenty of them. Not only do these gases contribute to warming, but one of them, nitrous oxide, also destroys ozone. Secondly, land becomes degraded. Continued fertilizer use over time drains the soil of its richness. The soil becomes acidic, excluding certain crops from being grown. But this also kills the ecosystem of the soil. The microbes and worms that brought fertility to the soil are killed. It is estimated that more than 30% of global agricultural land is degraded. Lastly, fertilizers are heavy water polluters. They leach from the soil into water systems, with several negative consequences. Ecosystems experience eutrophication, an event where algae undergoes rapid growth. Good for them, but bad for the ecosystem, because they use up all of the oxygen, resulting in the destruction of the organisms around them. Another consequence is that water reserves become acidic, and farmers are no longer able to use the water for crops without serious treatment of the water. Yet another consequence is that workers and rural residents suffer health complications, especially infants. A study conducted in India found that a 10% increase in the average level of fertilizer chemicals in water in the month of conception increases the likelihood of infant mortality by about 4.6%. Case upon case upon case demonstrates that the input-output view of fertilizers is disingenuously hermetic, cut off from the big picture. Another culprit of health problems are pesticides, and they too have several hidden costs. 1. Polluted water needs to be treated so that it can be drinkable. 2. People get sick, from the worker to the consumer. 3. Aquaculture and fishing industries downstream lose their stock to pollution. 4. Biodiversity is lost in and around farms. And 5. The manufacture of pesticides use energy, often dirty energy. Pretty et al. Estimated that the total unpaid cost of pesticides in the US is around $1.5 billion per year. China has a similar cost of $1.4 billion. Despite these hidden costs, the benefits surely outweigh the costs, right? Well, it's somewhat true. In the US, the value of pesticides for improved yields is $8 billion per year. Plenty of room to loop in the hidden cost. But in China, the value is only $750 million, meaning pesticides do more damage to society than good. You must be wondering, how can the value of pesticides vary so drastically? Well, there are various different types of pesticides, each with their own properties and different application techniques. But this brings us to an important point. The approach to dealing with the problem, pests and weeds, is too straightforward, too reliant on a simple understanding of the mechanics of nature, input and predicted output. In 1984, Kenmore et al. Discovered something completely unpredicted. Pest attack on rice was proportional to the amount of pesticides used, meaning that more pesticide equaled more pests. It seemed pests had played the reverse Uno card. What was happening required a different context, that nature was interconnected, because what was happening was that the insect pests' natural predators, like spiders and beetles, were being eliminated from the agro-ecosystem, allowing the insect pest populations to explode. These realizations led to the emergence of IPM, Integrated Pest Management, an approach that recognizes the complexities of agro-ecosystems, one that recognizes the subtleties. Instead of dousing one's field in 7 different pesticides, killing practically everything, IPM recommends a detailed approach based on the life cycle of pests and their interaction with the environment. And these approaches have yielded incredible results. Pretty et al. Analyzed 62 IPM programs across 26 countries, where they considered 4 cases. A. Pesticide use and yields increase together. B. Pesticides increase, but yields decrease. C. Both decrease. And D. Pesticides decrease and yields increase. They found that 60% of the programs fell in Sector D, where pesticide use decreased, yet yields increased. Proof that a recognition of the connectedness of nature is in fact economical. As part of this mechanistic reduction of nature, and crucial to the Green Revolution, was the dominance of the monoculture. One crop, one seed, one irrigation program, one fertilizer program, one harvest method. But is it really better than a diverse crop? Zhu et al. Had this question in mind when they conducted a study in the Yunnan province of China. They were interested in the effect a mixture of crops had on yields, especially how it influenced disease prevalence. This was important because as the Green Revolution progressed and the same crops were used over and over again, crops lost their genetic diversity, making them susceptible to diseases. Once again, the search for stability led to greater vulnerability to a crisis, a disease outbreak. With the cooperation of thousands of farmers, Zhu et al. Tested the mixture of 2 different varieties of rice versus a monoculture of each, and what they found was conclusive. Disease-susceptible rice varieties planted in mixtures with resistant varieties had 89% greater yield, and blast, the disease, was 94% less severe than when they were grown in monoculture. The experiment was so successful that after 2 years, they no longer needed fungicidal spray to control the disease. Not only was the disease prevalence severely reduced, but the mixed crop yielded more grain than the monocultures in all cases. It's clear from these examples that nature is complex, far more complex than the linear mechanisms that the Green Revolution was founded on. Whether it's irrigation that brings salt into the soil, or fertilizers that destroy ecosystems, or pesticides that do the opposite of what they're supposed to, clearly a new vision of nature was needed. And there have been movements to do just that. In 1983, Holling, a prominent ecologist, released a seminal paper entitled Resilience and Stability of Ecological Systems. In it, he argues for a new view of ecological systems, a resilience view, away from the presumption of predictability. He ends his paper by saying, where the stability view emphasizes the equilibrium, the maintenance of a predictable world, and the harvesting of nature's excess production with as little fluctuation as possible, the resilience view emphasizes the need to keep options open, the need to view events in a regional rather than local context, and the need to emphasize heterogeneity. Flowing from this would be not the presumption of sufficient knowledge, but the recognition of our ignorance. Not the assumption that future events are expected, but that they will be unexpected. The resilience perspective can accommodate this shift of perspective, for it does not require a precise capacity to predict the future, but only a qualitative capacity to devise systems that can absorb and accommodate future events, in whatever unexpected form they may take. Holling would go on to spread this view from ecological contexts to society at large. From ecological systems, it progressed to socio-ecological systems. In the 1990s, he founded a consortium of environmental scientists called the Resilience Alliance to promote this perspective. This was later brought together with other initiatives to found the Stockholm Resilience Center in 2007, a high-profile think tank that promotes resilience thinking in international environmental and development projects. Walker and Cooper, in their paper on the genealogies of resilience, track the spread of this resilience view. The National Strategy for Homeland Security report of 2007 called upon a culture of resilience to be constantly prepared for emergency, both in infrastructure and psychologically. After 9/11 and Hurricane Katrina, crisis was on the mind of Americans. The report emphasized that in this complex world, it was impossible to predict what crisis may be around the corner, whether it be terrorist threat, financial crisis, or environmental disaster. And right they were. The following year there was a financial crisis, and just over a decade later, a global pandemic. The financial world after 2008 shifted their approach. Andrew Haldane, executive director at the Bank of England, called for a change of perspective, to view the financial world as a complex adaptive system. At the time, the dominant approach for robustness was to stress test models, but it was blinkered by the normal distribution. Working probabilistically, it excluded outlier events, it excluded crises. Haldane responded by accounting for these outlier events by introducing scenario planning, where subjective expectations of the future are used to stress test models. It moved away from an over-reliance on the precise quantitative planning towards a more qualitative approach. The resilience approach was also adopted in development projects, with the UN being a strong proponent. In a report entitled Roots of Resilience, they say, resilience is the capacity to adapt and to thrive in the face of challenge. The report contends that when the poor successfully and sustainably scale up ecosystem-based enterprises, their resilience can increase in 3 dimensions. They can become more economically resilient, more socially resilient, and more biologically resilient. But they also warn that there is a Goldilocks zone. There are systems that are like depleted ecosystems with no capacity to reorganize after a shock. But there are also those that are too rigid to evolve, like calcified authoritarian regimes. This view of complexity was an important step forward, away from the command and control view of the Cold War period. But these examples of resilience have their pitfalls. In the world of security, the acceptance of crisis as inevitable shifted focus from prevention to response. They eschewed responsibility in the name of resilience. In finance, it was argued that because the market was a complex adaptive system, smarter than any one person, any one institution, deregulation should occur. And in development economics, it became a Darwinian principle, where the subject can be either not resilient enough or too resilient. Once again, focus was shifted away from prevention. The view of crisis shifted towards an almost exalted view, where crises are natural, encouraged even. The cycle goes from growth to conservation to release or catastrophe, and finally to reorganization or creative renewal, before the cycle repeats itself. This cycle became a virtue in and of itself, that the cycle should repeat itself, that crisis should happen. A lack of predictability inspired a lack of agency. The inevitability inspired an excuse. Instead of holding on to a pragmatism, this view of a complex system served to dissolve grounded action into intellectual ether. Despite these wrong turns, the recognition of the world as a complex adaptive system was important, because it was a truer understanding of how things work. It recognized that when one tugs at a single thing in nature, he finds it attached to the rest of the world. But we cannot allow ourselves to be dissuaded from grounding our approaches in a pragmatic philosophy. Instead of relinquishing our agency to an abstract concept, we should embrace the power of bottom-up, distributed wisdom and combine it with our best attempts to foresee. Because, for all its blind spots, the mechanistic industrialist approach to the world was active. It made things happen. It is just that now we must make things happen while keeping in mind the interconnected context. We must be pragmatic and take action with deep consideration. Our future depends on it. We predicted that the world was vulnerable to a global pandemic, but we did not prepare. Now we are tragically reminded of its consequences every day. We predict that climate change increases the frequency of natural disasters, so let's be pragmatic. Let's take preventative action against climate change, against the next epidemic, against the next financial crisis. Let's allow the acknowledgement of complexity to clarify our thoughts. Let's learn from the wisdom of nature. I'll end with another quote from John Muir. "The clearest way into the universe is through a forest wilderness."